So I'm looking to fill out my table. Who could tell me what they got for the square inches and how they knew? Grant.
I got 13.5, and I saw the rule was multiplied by 3, so I just multiplied 4.5 by 3.
And so you get and then for the next one, then did you get 33 halves?
Yes.
Okay. So he said something about times 3 for the inches. How could we go from area then to the inches? Divide by 3. So did we have a 12 and a 15 and a half?
Yeah.
Okay, so this way, times 3. This way, divide by 3. So if I'm talking area of a parallelogram, it tells us a parallelogram. What's the equation? Area is equal to base times height. But guess what? The height has to be what? 3. Would you agree? The height has to be 3. Because the changing base is the only thing changing the area. Okay? Is there an equation what's the equation then to go from base? If I know the area, then to the base. Yeah, Micah.
Area divided by 3 equals base.
Okay. Area divided by 3 equals base. So one thing we've noticed and worked on is if we do the same thing to both sides of an equation, we have a new equivalent equation. So in theory, these should be equivalent since we used them back and forth. What's one step I can use to get from one to the other then to prove this? Yeah. Yeah, but what? Specifically to this situation.
Divide.
Okay, divide what by what?
Divide by 3.
Okay, here's my 2 equations. We're looking to make sure to prove one to the other.
On one of them, you divide by 3.
Which one, though?
On B, you divide by 3. No. B, you'd multiply it by 3 to get...
So you're saying I can multiply this one by 3,
Yeah.
and it's A equals B times 3? Okay, that shows your equivalent right there. Or on this one, we could divide both sides by 3, and we get base equals area divided by 3. Why would we want 2 different equations? Why not just A equals BH? Why 2? Yeah. Yeah, depending if I'm given the area, I'd want B equals. If I'm given the base, I want A equals, right? That way, otherwise, we're going to have to solve for things sometimes. We can front load the solving, just use 2 different equations for the 2 different things. You guys kind of innately did it. This is a simple example on purpose. We'll look at more complex examples coming up. So here's our first problem for today. There's a parade, and it's not cool, but I don't know. You guys ever see after parade, people kind of trash the place. It's not cool.
Yeah, it's not...
Clean up your area after a parade, okay? But there's volunteers to clean it up. The stretch of the parade, it's a pretty good parade, 2 miles, 2-mile parade. And the amount that each person is going to clean up is dependent on how many people they have to clean it up. And they're going to split it up equally. So you're going to see how much road 8 volunteers need to each clean up, 10 volunteers, 25, and 36. Then you're going to write an equation that you can use for any number of volunteers to see how much road they need to clean up. All right, so looking around, I see most of us did something similar. I'm going to say I've got 2 miles divided by 8 volunteers. I've got 2 miles divided by 10 volunteers. I've got 2 miles divided by 25 volunteers and 2 miles divided by 36 volunteers. If you simplified, cool. If not, you're still all right. So who can give me an equation that will tell me how much road, no matter how many volunteers I have? Spencer?
2 divided by B equals what?
So it said length of road, so let's go with that. But yeah, 2 miles divided by the n number of volunteers. So I'm just going to use the variables they provided, but you're on the right track. So make sure, remember, a great way to know if your equation works well is to be able to summarize your situation, right? The length that each volunteer will do is equal to 2 miles divided by the number of volunteers. We good? Okay, so now what you need to do is give how many volunteers would be needed for these lengths of road. Same premise, it's still 2 miles, but here's the length of road. We would need to know how many volunteers if each volunteer is going to do this length of road. All right. So I think you guys, what you probably did is took your 2 miles and divided it by how far each needs to go to get the answer of how many volunteers, not miles.
I just know that 4 is 2/5.
Okay, so 2 divided by 2/7 is 2 times 7/2, which is 7 volunteers. 2 divided by 1/8 is 2 times 8, which is 16 volunteers. 2 divided by 6/45 is 2 times 45/6, which is 45 divided by 3, or 15 volunteers. Okay, question.
Well, I mean, it kind of, for B, it kind of gives you the answer, which is 7. And then for D, you know that if it's going to be 2, then you can just divide 45 by 3.
Yeah. So do you guys see why I chose to use fractions? They all worked much nicer. I could just... Okay. Then what's an equation that will work? Well, the number of volunteers was always equal to the number of miles, 2, divided by how far they each need to go, L. Now, last time we said the length they each need to go is 2 divided by n, right? We should be able to prove that these are the same thing by doing the same thing to both sides. Would you agree? If we can do the same thing to both sides, get to be the other one, then we know they're equivalent. So watch what I'm going to do. For this one, I'm going to multiply both sides by n. That gets rid of the divide by n. And that means 2 is equal to n times L, which means the number of volunteers times the number of miles each volunteer would do needs to total 2 miles. Like, in context, it still makes sense. Then, to get n alone, I'm going to divide by L. Check it out. The number of volunteers equals 2 over L. I did the same thing to both sides to get back to my original equation. I'm just doing that to prove what has to be true about my two equations then. If I did the same thing to both sides to get from one to the other, what has to be true about them? They're equivalent, right? They're the same. Why would I want two different equations though?
So you could find how to go each way.
Yeah, volunteers to how far they would each need to do, and how far they each need to do to number of volunteers. The two different equations will help me go the two different directions I would need to go, depending on what information is supplied and what information is wanted. We're going to do another one. We're going to get a little extra constant in there. We've got a tank of water, and it's got 124 liters, and it's gaining 9 liters per minute. It's your job to say how much is in there after 4 minutes, 80 seconds. And then you're going to go the other way. You're going to go liters to minutes as well, and we're going to compare the two equations that we make using the situation. This one might take a little longer, maybe like 5-6 minutes. Looking at the minutes, for one, I personally like to use the equation. So I wrote the equation first. Remember, you can always summarize a situation with your equation if you write an appropriate equation. I have 124 liters. I'm adding 9 liters per minute to get a total number of liters. So for 4 minutes, I have 124. I'm adding 9 a minute for 4 minutes, and that total is 160 liters. For 80 seconds, I have 124 already in there, and I'm going to do 9 times 1 1/3. So I'm going to do 4/3. Here's what I'm going to do 4/3. 4/3 times 9 is kind of easy. It's 12. So 124 plus 12, 136. Anybody else use the fraction there to make it easier?
Yeah. No.
Anybody use 1.2? I saw that. I see that sometimes. Yeah, you can't do 0.2 because 20 minutes out of an hour is 20 minutes out of...
I thought it was 1.33.
It is 1.3 repeated, but good luck multiplying that nicely by 9. Watch this. 9 times 4/3. Cross simplify, I got 4 times 3. Right? So, I'm just going to keep promoting those fractions because fractions are where it's at.
Fractions are friends.
So next, when I made this next equation, I said to get my number of minutes, I'm going to take how much is in the tank. So let me point these out. How much is in the tank? I'm going to take the 124 out that were already in there. And then we'll divide that by 9 for the 9 per minute. And that'll give it to me. So, I might need your calculator help on this one. The number of minutes for 151 is how many minutes? You guys don't have me? 3 minutes? Okay, the number of minutes for 191. Yep, 7.5. Okay. And for 270,
16.25.
60 and a quarter. 16 though, not 60, right? Okay. So why would I want two different equations again? Well, if I want minutes, it's going to be much easier to use this. If I want how much is in the tank, it's going to be much easier to use this. Okay, now, what I'm going to show you is the biggest new part, okay? The biggest new part of what we're doing. So let me see if I can get this. I'm going to give us a nice clean page to look at. Let's go with, I got to find what I want here. Oh yeah, we're going to kick it old school right here. Boom. So, here's our original equation. 124 liters plus 9 per minute to get a total. We're going to prove that the two equations are equivalent, right? I said also, not P. The number of minutes is equal to taking how much is in there, taking out 124, and dividing all that by 9. To get equivalent fractions, or equations, if I do the same thing to both sides, it makes the new one true, correct? You guys would agree with that?
Yeah.
So, I'm going to get M alone. To do that, I'm going to first subtract 124. So that means 9 per minute is the total minus 124, which makes sense. The additional is associated to the 9 per minute. Then, to get M alone, I'm going to divide by 9. But you guys notice?
Same thing.
Samesies, okay? What do you also notice? What does my answer have in it?
A y-intercept?
No, it has a variable. That's what I want to point out. My answer has a variable in it. Okay. Well, no, this isn't my answer. That is what the answer will give you, right? So sometimes when we're solving equations, we're going to get like letter equals stuff with a letter in it. It's not just going to be like x equals 4. Sometimes it'll be like x equals 2y minus 9 or something. Okay? Did any of the principles of mathematics change? No, if I did to one side, I did it to the other to keep an equal equation. None of that changes. No big ideas change. So it might not feel good to like get an answer. Like something you could be asked is something like area equals 1/2 base times height, and they want you to solve for b, right? The goal is going to be b equals something. Well, if I solve this for b, am I just going to have a number? No. B is going to equal stuff with letters in it. Okay? And that's okay. That's math. The reason we want the additional equations is so we can do additional things with those equations. All right. We already did that. I want to look at this, make sure we're good. Can we solve an equation for a variable? Yes, we did it like 3 times today. And to solve for a variable, we understand that our answer can and likely will have a variable in it. You're going to do the lesson summary in your packet, friends. That's it. Back at your assigned seats.